the chain rule gives you a formula which makes use of a substitute. And this formula you can use to differentiate slightly more complicated functions. So the chain rule looks something like this. dy by du times du by dx. Okay, so here's what I mean by that. Let's say you have just a regular function y equals, let's call it x plus 1 all to the power of 6. Something like this is going to be complicated to differentiate if you're just going to do it normally. You're not going to expand it. Expanding it is going to take forever. And the only way to expand this would be using binomial. So first you've got to use binomial and then you have to differentiate each term. Nah, that's going to take forever. So what you can do is you can make use of the chain rule and have a substitute. So typically you want to make u equal to the part of your function which is making things complicated, right? Let's say if you had x to the power of 6 and you had to differentiate that. That's easy. The reason why this is difficult to do is because of this part. The x plus 1, the plus 1 is making things complicated. So you can have a substitute and make u equal to that x plus 1. And then you can rewrite your function as u to the power of 6. Now you can work out dy by du, you can work out du by dx, and then times it together. Done. Nice and easy. Okay? So let's have a look at this example. Given that y equals 3x to the power 4 plus x all to the power 5, find dy by dx. So the same thing as before. We're going to make whatever's making things complicated equal to u. So we're going to let u equal 3x to the power 4 plus x, which means y now equals u to the power 5. And now we're going to differentiate two separate things. We're going to work out dy by du, so 5u to the power 4, and du by dx, 12x cubed plus 1. Okay? Now, we're going to make use of the chain rule, which looks like this. Dy by du times du by dx. My dy by du is 5u to the power 4 times du by dx. Like this. This gives dy by dx. Now, substitute back in what your u is. So 3x to the power 4 plus x all to the power 4 times 12x cubed plus 1. Okay? Simplifying this is going to take forever, so you don't need to. Just write the brackets next to each other as a multiply, so instead of the times in between. And there you go, that's it. That is the chain rule. Let's say you have a slightly different scenario. Let's say you have something like this. Let's make it a bit bigger. So now you have sine to the power of 4. When you have something like this, you are going to rewrite your function. You're going to write it as sine x all to the power of 4. And now you can use the chain rule. You're going to let u equal sine x, which means y equals u to the power of 4. Can you try and finish this off for me, please? So you're going to do du by dx, which would be cos x, dy by du, which would be 4u cubed, and now you're doing dy by du times du by dx. So 4u cubed times cos x, which is 4 sine x cubed times cos x, which we can write as 4 sine cubed x cos x. That would be your final and most simplified answer. Okay, so what about something like this, where your function is a bit more complicated and it's not in brackets straight away? In this case, you want to write it in brackets first. How would you write root 5x squared plus 1 in brackets? You would do 5x squared plus 1 all to the power of a half. And now you can make use of your chain rule. So, can you try that for me, please? So you can let u equal 5x squared plus 1, and then y equals u to the power of a half. So du by dx would be 10x, and dy by du would be a half u to the power of minus a half. And to work out dy by dx, you're going to times those together. A half u to the minus a half times 10x, and you can sub it in. A half times 10x is just 5x. 5x times 5x squared plus 1, all to the power of minus a half. That's your dy by dx. The question says, find dy by dx at 4, 9. So you're going to sub in x equals 9. Sorry, x equals 4. Your y equals 9. X equals 4. You're going to plug it into that. And when you do, dy by dx equals 20 over 9. Okay. This question. This is the last one I'm going to go through, and then you're going to have some questions to do on your own. In this case, if you notice, your function is in terms of y, it's not in terms of x. So if you were to differentiate this, you would be working out dx by dy, technically. But that's not what you want. You want dy by dx. So the rule that you're going to use is dy by dx is equal to 1 over dx by dy. So all I want you to do is differentiate, work out dx by dy, and then flip it upside down. So can you try that for me, please? Can you work out dx by dy here? So you should get 3y squared plus 1. So dy by dx would be just 1 over that. And now, to find the value of dy by dx at the point 2, 1, you're going to sub y equals 1. And when you do, dy by dx is a quarter. That's it. Nice and easy. And that is pretty much the whole chain rule. I've tried to include multiple scenarios because you're going to get multiple scenarios. So if you have a trig function with a power, now you know how to do it. If your function is in terms of y or instead of x, now you know how to differentiate that as well using the chain rule. So that being said, I've put up questions 1 A and D, 2 A and D. Can you please try and give those a shot? Okay, first one. Your substitute will be what? 1 plus 2x. So you let u equal 1 plus 2x, which means y equals u to the power of 4. Du by dx is just 2. Dy by dx is 4u cubed. And now, when you multiply 4u cubed times 2, which is 8u cubed, and when you substitute 8 times 1 plus 2x, all cubed. There you go. That's your final answer. Next one, it's 1 over 3 plus 2x. What we're going to do is rewrite 1 over 3 plus 2x in terms of brackets. Like this. So all to the power of minus 1. U is 3 plus 2x. Y is u to the minus 1. Du by dx is 2. Dy by du is minus u to the power of minus 2. And now, using the chain rule, you should have minus 2 u to the power of minus 2. So minus 2 times 3 plus 2x, all to the power of minus 2. And if you want to take it a step further, you can write it like this. I would say it's best to write it like this because in the original question, that was the format. So you want to try and give your answer in the same format as the question, ideally. Okay, next one, 2a. 2a is a little complicated. You have e and you have trig in the same function. So, the thing making this complicated is the cos. Let's say if it were e to the power of 2x, that's easy, you have a rule for that. Cos is what's making it difficult. So, I would say let u equal cos x, which means y equals e to the power of u. Okay? Du by dx would be minus sine x, and dy by du would be e to the power of u. When you differentiate e, it stays the same. E to the power of x differentiated is still e to the power of x. It's only when you have a number in front where the rule changes a bit. Okay, so now, want to keep it in black. Dy by dx is going to be minus sine x times e to the power of u. So minus sine x e to the power of cos x. There you go, done. Okay, the last one was 2e. Sine 3x squared minus 2x plus 1. Okay. Sine 3x squared minus 2x plus 1. You're going to make u equal to your quadratic. Y equals sine u. Let's write that u a bit closer, like that. So du by dx is 6x minus 2. Dy by du is just cos x, cos u. Now, dy by dx is going to be 6x minus 2 in one bracket, and then cos 3x squared minus 2x plus 1. There we go. That's after the multiply, and that's after the resubstitute of u. There you go. Chain rule.